As part of this beginner level course for Linux, so far we have explored quite a few Linux commands. In this sectional module, you will be exploring a new set of Linux commands from the perspective of monitoring and managing Linux servers using system commands. In the process of exploring all the important commands, first we will set up EC2 instance on AWS using Ubuntu 20.04. Once it is provisioned from AWS, we will take care of installing few softwares. The softwares which we are going to install are nothing but Apache 2, Mongodb, and we will eventually install jupyterlab as well. We will understand how to install these softwares using tools such as apt. Once we install softwares, we will also explore systemctl command to manage the applications associated with these softwares. Then we'll actually go to the details about how to get CPU or load average using a command called as uptime. Then we'll explore ps command in detail, which actually gives us details about the process. On top of ps, another important command which will be covered quite extensively is nothing but lsof. Once we go through these, we'll also explore a very important command called as stop. Make sure you go through each and every lecture in this sectional module and be comfortable with respect to all the topics that are covered. It is very, very important for you to go through all these and understand these important commands. These commands will facilitate you to troubleshoot quite a few issues with respect to applications that are deployed on Linux servers, and this section is very, very important for all kinds of users who are going to support their applications on Linux. As part of this sectional module, we'll be going through the details related to monitoring and managing Linux servers using system commands. In this lecture, let's make sure we have Ubuntu 20.04 server. Once we have Ubuntu 20.04 server, we should be able to take care of all the tasks that are relevant to monitor and manage Linux servers using commands. You can also use Ubuntu that is set up using WSL on Windows. However, there might be few limitations. It's better to have a full-blown Ubuntu-based server. One of the ways to get a full-blown Ubuntu-based server is by provisioning EC2 instance with Ubuntu 20.04 on AWS. You can pick any Ubuntu 20.04 server and you should be able to go through the sectional module without any challenges. That being said, as of now, I am in the AWS console. Let me create a new instance. For that, I have clicked on launch instance. I'll be naming it as syscommands demo. That is the name of my instance. Let me select this. Let me make sure I select Ubuntu 20.04. Most of these commands will work on Ubuntu 16.04, 18.04, 20.04 as well as 22.04. There might be some commands here and there which might not work. Also, most of these commands will work on even Red Hat, CentOS, SUSE Linux, etc. Here we are actually focusing on Linux commands more than Ubuntu specific commands. However, there might be some commands which will work only on Ubuntu but not on others. Now, to take care of all the details with respect to system commands, instead of using t2.micro, which comes as part of free tier eligible, I'll be choosing t2.medium. t2.medium comes with 2 vCPUs and 4 GB memory. You should pick this up. If you are using your own AWS account, keep in mind that there will be some nominal costs with respect to this server. You can actually go through AWS pricing calculator and you should be able to get the details related to pricing associated with this instance. Now, when it comes to the key pair, I'll be using jsdemo.pem or jsdemo. That is the key pair name. The private key is nothing but jsdemo.pem, which is already downloaded, and hence I should be able to connect to this without any issues. Now, let's make sure we choose only one instance. You can see the number here. You can actually click on launch instance. It will take care of launching the instance for us. Once you come here, you should be able to click on view all instances. You can actually see all the instances here. However, in this case, we are interested in only the syscommands demo EC2 instance. You can search and narrow down to syscommands demo EC2 instance. Let me select this. Let me copy public IPv4 DNS. Now let me go to my client. My client is nothing but Ubuntu based server which is set up using WSL on Windows. As of now, it is not launched. I have to launch it. First, I have to go to Windows PowerShell. Once I'm in the PowerShell, I should be able to say WSL. It will take care of launching Ubuntu 20.04 VM on this Windows machine. This will act as client. If you relate to this picture, as of now, I am in this one. Our EC2 instance is this. We have just provisioned. It will only have SSD. It will not have Apache 2 or MongoDB or any other server. We'll actually take care of installing these so that we can actually go through all the important commands which are relevant to manage Linux servers. Now let's go back here. Now I can say ssh-i .ssh gsdemo.pem. This is the private key related to the key pair which is used while creating the EC2 instance. Now we should be able to say Ubuntu @ paste the public IPv4 DNS, hit enter, say yes when prompt. Now you are inside the EC2 instance. This is how you should be able to create EC2 instance with Ubuntu 20.4 so that you can actually practice all the tasks which are going to be demonstrated as part of this sectional module. As a server with Ubuntu 20.4 is ready, let's go ahead and understand a tool called as apt. Apt is typically used to manage softwares in Ubuntu. Once we go through apt, then we'll actually go through the details about installing Apache to MongoDB, etc. in the pursuit of understanding the commands which are used to manage Linux servers. Apt is also one of the commands which can be categorized under managing the components on Linux servers. Let's go through the details about apt in the next lecture. As part of this section module, we are going through the details related to monitoring and managing Linux servers using system commands. In that process, we made sure that we have Ubuntu 20.4 server. Even though I have Ubuntu 20.4 set up using WSL on Windows, I have provisioned EC2 instance from AWS with Ubuntu 20.4. You can pick any Ubuntu 20.4 and explore all the commands we are going to cover as part of monitoring and managing Linux servers using system commands. As the Linux-based server with Ubuntu 20.4 is ready, let's go ahead and explore a command called as apt. It is typically used to manage softwares on Ubuntu-based servers. To get more details about apt, you can say apt then space -- help. You should be able to see some of the commands which are there under apt. These are most used commands. You should be able to list all the packages based on package names using list. You can also perform search using search. Also, you should be able to get details about a particular package using show. You should be able to install using install. You can reinstall. You can remove. You can update. Also, you can upgrade. Most of the times we use install, update, and upgrade. Update is primarily to update list of available packages. To use apt effectively, you should understand this term called as package. Keep in mind that Ubuntu is open source operating system. There is a community supporting Ubuntu. All the softwares are made available to you by the community. You just have to make sure you install them. When they say package, it is nothing but the software that is made available by the Ubuntu community to you. You can also package the verse and you can install as well. In this case, if you try to understand this statement related to list, it says list packages based on package names. It will just list all the packages that are available at this time on this server. What update will do is it will actually go to the public repositories of Ubuntu and it will try to update the list of available packages. Sometimes when we try to install, if it is not installed, then if you say apt update and then if you use apt install, it will work without any issues. Also keep in mind that to run apt, you need to have relevant permissions. Without relevant permissions, you will not be able to use apt. As long as the user is sudo or super user, the user should be able to use sudo command and should be able to install softwares on Ubuntu servers using apt. Developers, testers, etc., they might not have required permissions to use apt. They might have to work with the system administrators to take care of installing softwares using apt. That being said, let's go through some of the commands so that we understand what apt is all about. Also, we'll install a software called as Python 3-venv so that we understand how to actually take care of installing a package or software using apt. In this case, I can say apt list to actually get the details about all the packages. The session is hung. Let me close it and let me reconnect and then take it further. In this case, again, I'm going to WSL. Then I'm using the same SSH command which I have used earlier to connect to the Ubuntu server on AWS. Now I should be able to use apt list. You can see that it have returned quite a few packages here. Keep in mind that these are not the packages that are installed on this system at this time. There might be some of these that are already installed here. Some of them are not installed yet. For example, OpenSSH server is installed. You can actually say apt list, then pipe to grep, then say SSH. You should be able to see all the packages related to SSH. To use SSH, we need to have OpenSSH client. And you can see the details here. It said installed here. And also it is automatic, which means it is automatically installed for us as soon as we set up Ubuntu on this machine. Out of all these SSH based packages, only those which say installed are actually installed on this machine. Now let's search for Python. Now to search for all the packages related to Python, I have used this command. You can actually review all the packages that are there with respect to Python. You can see some of them are actually installed. Some of them are not. Now there is a command called as python 3 -m venv, which will facilitate us to create virtual environment. Let's try running that command to see if it will work or not. In this case, I'm saying python 3 -m venv, then testing. Let me hit enter. You can see that it says the virtual environment was not created successfully because ensure pip is not available. You can actually go to the rest of the statement. It is saying use this command to install python 3.8 -venv. Also, it is actually saying you may need to use sudo with that command. If you are using root, you should be able to install directly. If not, if the user is sudoer, you should be able to use sudo. But before using this command, let's review the packages here. If there is any package by name python 3.8 -venv, you can actually go to the details. There is no python 3 -venv. Now, if I say apt install python 3.8 venv as suggested, most likely it will not work. Let's try and see whether this command will work or not. For that, I'm actually copying this. Now we should say sudo and then paste it. Let's hit enter. You can see that it is complaining saying package python 3.8 -venv has no installation candidate. Now let's run sudo apt update. It will take some time to run this command. Once it is completely executed, we'll actually take care of reviewing whether python 3.8 -venv package is available or not. Once we confirm, then we'll actually try to install it. Now the command is executed. Let's use this command once again. In this case, I'm actually saying grep python, grep env, hit enter. Now you can see that there is a package by name python 3 -venv. Let's also go back to the original command which we have validated. It is nothing but this one. Now let's scroll up. Earlier we haven't seen python 3.8 venv here. These are all added new. They were not there earlier. Let's check for python 3.8 -venv. I think it might be at the bottom itself. Let me see. Yeah, you can see here. Python 3.8 -venv. Earlier it was not there. This time we can see it. Now we should be able to use apt install without any issue to install python 3.8 -venv. Let's hit enter so that python 3.8 -venv is installed on this machine. This is how you should be able to install packages by updating the packages first if the package is not available. Now let's go to apt -help output once again by running this command. You can see that on top of installation, you can also take care of reinstallation, removing as well as upgrading the package. In this case, if you'd like to uninstall python 3.8 venv, you can use the remove command and you should be able to uninstall. Also, you should be able to use show to get more details about a package. Let's say apt show, then python 3.8 -venv. You can see all the details with respect to this package. You can actually go to the details and you can actually see that it is manually installed by reviewing these details. This is how you should be able to use apt to manage packages or softwares on Ubuntu based servers. As we got an overview of apt, let's go ahead and use apt to install additional softwares on this machine. In the process of going through the details related to monitoring and managing Linux servers using system commands, in the previous lecture, we have gone through the details related to apt. Now let's use apt and install Apache Web Server and MongoDB on Ubuntu. On Ubuntu, the Apache Web Server is known as Apache 2. Now you should be able to use sudo, then say apt install, then Apache 2. It will take care of installing the software for you. However, it will prompt you to confirm whether you would like to install or not. If you don't want to get the prompt, you can say space -y. It will not prompt you. Let me delete -y here. Let me hit enter. You can see that it is asking us to confirm whether we want to continue or not. You can hit enter. As y is in capital, it is default. Even if you hit enter, it will actually take care of installing it. However, if you say n, it will be discarding from here. Let's say n and come out of it. Now we should be able to say space -y. It will take care of installing Apache 2 on this machine without prompting us. You can see that the installation is already started. Now Apache 2 is successfully installed on this machine. Let's go to the details about installing MongoDB as well on this machine. For that, first we need to make sure we go to the documentation, and then we can actually take care of installing MongoDB on this machine. In this case, we are trying to install MongoDB on Ubuntu 20.4. We can actually open the browser, and then we should be able to search for install MongoDB on Ubuntu 20.4. You can go through one of these two articles and you can actually take care of setting up MongoDB on Ubuntu 20.4. DigitalOcean articles are also reliable. You should be able to use the articles from DigitalOcean. Also, you should be able to go to the official documentation of MongoDB from mongodb.com itself. Whatever is convenient to you, you can pick up. However, you need to make sure that you are actually reviewing the article related to the operating system which you are interested in. In this case, you can see that it is talking about Ubuntu 20.4. Now, you can actually scroll down. You can see that there are a few things which you need to take care before actually installing using apt. Before actually executing these things, let's directly jump onto the section where it says apt install mongodb-org. I have copied this command. Now let me paste here. Let's see what happens. It is saying unable to locate package mongodb-org. Even if I say sudo apt update, then run this command, it will still complain. The reason is MongoDB is not available as part of the packages that are provided by the Ubuntu community. MongoDB packages are made available by the vendor who took care of developing MongoDB. In this case, mongodb.com is the website of the vendor. We need to make sure we update the packages from the vendors. The way you can do it is like this. You have to go to the official documentation of the software which you are going to install, and then you can take it further. First, you need to make sure you copy and paste this. In this case, it is actually downloading this server -4.4.asc into this machine, and then it is updating something called as apt key. Don't worry too much about these details at this time. Just copy paste the details that are provided from the articles and we should be good to go. Once this command is run, we should not be seeing any errors, and also we can actually run this command to validate whether the apt key is set up for MongoDB or not. For that, you should be able to copy this, then paste here, hit enter. You can review the details related to the MongoDB apt key here. Now the next step is to run this command. It will take care of providing the required information to look up for additional packages from which the softwares can be installed. Let's copy this. You can see that it is trying to create something under etc apt sources.list.d. Let me go here. Let me say ls-ltr etc apt sources.list.d. As of now, it is empty. I have pasted the command which I have copied. You can go to the command here. It is just adding something into this file. T will take care of adding whatever you are saying here into the file. So a new file will be created here and this entry will be added to it. Let me hit enter. Now it is updated. You should be able to validate by running ls-ltr command first. Then cat etc apt sources.list.d, then mongodb-org blah blah blah, hit enter. You can see the entry here. When we actually use apt update and then apt install now, it will take care of using this additional information and update the packages. Once the packages are updated, we should be able to install using those packages. Now we should be able to say apt update. However, we have to use sudo. Let me use sudo here. It will take care of adding additional packages. You can review the details here. It have actually connected to MongoDB repos and it have downloaded the packages from there. Now we should be able to use sudo apt install with the package name. It will take care of installing the package for us. The package name is nothing but mongodb-org. Let me copy. Let me go here. Let me paste. Hit enter. It will take care of installing mongodb-org. However, we need to confirm. Now it is actually installing the required package related to MongoDB. This is how you should be able to use apt to actually install the softwares. As the softwares are installed, we need to make sure these are also started. For that, we need to use a command called as systemctl. Let's go to the details related to systemctl and validate whether these are up and running or not. If not, we'll make sure these are up and running by using appropriate systemctl commands. Those details will be covered as part of next couple of lectures. At this time, we are going through the details about monitoring and managing Linux servers using system commands. In the previous lecture, we have gone ahead and installed Apache 2 and MongoDB on it. However, the background process related to these might be up and running or they might not be up and running. We should be able to use either service or systemctl to take care of managing the background process associated with the application servers or database servers. That being said, let's get an overview about systemctl or service, then we'll actually take it further. In this case, I'm going back to the Ubuntu machine. Now let me actually say systemctl, then --help to get the usage of systemctl. It is actually used to query or send control commands to the system manager. The control commands are nothing but start, stop, restart, etc. Start will start the stopped process. Stop will actually stop the started process or running process. Restart will take care of stopping and starting. Status will actually give us the details about the process. We can also use service. Let's come out of this. Let's say service --help to get the usage of service. It doesn't give too much of documentation. Keep in mind that service is the legacy, systemctl is the modern command. You can use either of the commands to manage process associated with the applications or databases. Let's use these commands against SSHD. It is available out of the box when we actually provision Ubuntu based machine from AWS. Let's go back to that. Let's say systemctl, then status, then SSHD. This is the syntax with respect to the systemctl command. You have to use systemctl, then you have to use subcommand such as start, stop, restart, status, etc. Then you have to give the process name or application name here. Now you should be able to hit enter. You should be able to see the details with respect to this process. As of now, it is up and running. Let's see how to get these details using service. Even though service gives the same output for us, the syntax is different. And you need to make sure you understand the difference between systemctl and service with respect to the syntax. We can hit Ctrl C to come out of it. Now we should be able to say service, then the process name or application name. In this case, it is nothing but SHD, then status. This is the syntax with respect to service. When it comes to systemctl, it is systemctl, then the subcommand under systemctl, then the application name or process name. When it comes to the service, the application name goes immediately after service. The application name will be followed by status. Now we should be able to hit enter and we should be able to see the output. The output is same as what we have seen earlier. As part of this output, you should also understand the relevance of this. This actually confirms that it will be automatically started on reboots. It is actually enabled. We'll actually go to the details about enabling and disabling as part of the next lecture when we try to use the systemctl command against the Apache 2 or MongoDB. That being said, this is how you can actually get the status of a process using either systemctl or service. I'll be using systemctl going forward. Now let me come out of this. If we connect to remote Linux servers from the clients using SH, if there is idle time, at times the sessions get hung. We have to close and we have to restart and then we have to take it further. It can be counterproductive. Let's go to the details about updating the property and also the relevance of bouncing using appropriate commands. In this case, we need to update property in sshd_config. For that, we should be able to say cd etc ssh. In this, you should be able to see all the properties files. The property file which is relevant is nothing but sshd_config. Let me go to sshd_config. As I have logged in as Ubuntu, as this is owned by root, I have to use sudo command to update sshd_config. Keep in mind that if you are not administrator, you will not be able to perform this task. Also, if you are not comfortable with VI editor, you have to be careful. You can use editors such as Visual Studio Code with remote development and you should be able to update the file. However, updating sshd_config is sensitive. Make sure you go through the details only if you are really comfortable with it. If you are not comfortable with it, we can actually have a working session and we'll take care of updating your sshd_config file. Now, let me say sudo vi etc ssh, then sshd_config. In this case, I am passing a fully qualified path. I can also use the relative path directly because I am already in that folder. Now I can run that command to get into the file. We should be able to go till the end. Towards the end, you can actually see an entry which is commented out by name client alive interval. The value is 0. By default, it will actually try 3 times when client alive interval is 0 because client alive count max is 3. Then the session will be killed on the server. As the session will be killed on server, the client session will hung. Now you should be able to change this value to whatever value you want to. Then you have to bounce SSHD. Once it is bounced, it will not be get into the hung state very frequently. In this case, I'll be actually changing it to 300. 300 means 5 minutes. It will be alive at least up to 15 minutes even the session is idle. Now let me save and come out of it. Now we have to bounce it. If you try to use systemctl directly like this, to bounce it will not work. Status will work, but bounce will not work. The command to bounce is nothing but restart. Then you have to give the process name, which is nothing but SSHD. You can see that it is saying authentication is required to restart, and it is asking for the password. However, there is no password login on this machine. I have to actually use sudo before this to actually restart SSHD. To use systemctl start, stop, restart, etc., you need to have elevated permissions. You should be able to inherit elevated permissions for this user called as Ubuntu using sudo. Now let me hit enter. Now it should be restarted. We can actually check the status by saying systemctl, then status sshd. You can see that it is up and running. Now let's come out of this. As the property is updated, even though the session is idle for 15 minutes, the session will not hang on the client side. This is how you should be able to use systemctl to take care of managing the process. As we understood the purpose of systemctl as well as service, let's go ahead and make sure the process related to Apache 2 as well as MongoDB are up and running. If they are not up and running, we'll make them up and running, and also we'll make sure they will be up and running on reboots. Let's go to those details as part of the next lecture. As part of the previous lecture, we have gone through the details related to systemctl or service to manage the services or process associated with the applications or databases. In this lecture, let's go through the details about reviewing the status of Apache 2 as well as MongoDB using systemctl. If they are not up and running, we'll make sure they are up and running. Let's go back to the Ubuntu based machine here. I'm already logged in into the EC2 instance where Apache 2 as well as MongoDB are set up. Now we should be able to say systemctl, then status Apache 2. You can see that it is up and running, and also you can see that it is enabled, which means on reboots it will be automatically be started. We don't need to explicitly start. Now if we check the status of MongoDB by saying systemctl status, then mongodb.service or mongod, you don't need to have this extension called as .service. You can see that it is loaded, but it is disabled, and also it is inactive at this time, which means it is not running. To start, we just have to say systemctl start mongod. However, we need to use sudo to actually use start, stop, restart, etc. And hence let me say sudo systemctl start mongod. Now it is started. Now we should be able to check the status by saying systemctl status mongod. You can see that it is up and running, however it is disabled. Now if I reboot this machine, I should be able to say sudo init 6. It will take care of rebooting the machine. If the machine is rebooted, Apache 2 will be up and running, but not MongoDB. Let's see. In this case, I'm actually rebooting the machine. After running the command, make sure you wait for a couple of minutes, and then you should be able to log in. I have already waited for a couple of minutes. Now I'm trying to log in onto this machine. I have logged in. Let's run the same commands again. First, I'm checking the status of Apache 2. You can see that it is running without any issue. However, when it comes to MongoDB, you can see that it is in dead state or inactive state, which means it is not started. Now let me actually enable it. To enable, I just have to say sudo systemctl enable MongoDB. I'm using this command as reference. I'm replacing start with enable. Now I can hit enter. You can see that it have created something called as symlink. Now if you check the status of MongoDB, you can see this status is changed to enabled, which means now if I reboot the machine, MongoDB also will come up automatically. For now, let's use the start command to actually start MongoDB. Again, we have to use sudo to actually start. Let's add sudo at the beginning. Now it should be started. We can check the status by saying systemctl status MongoDB. You can see it is up and running. Now we should be able to reboot it once again. Make sure to wait for a couple of minutes after running this command. I have already waited. Now let me run this. First time the server is not completely up and running, that's why it failed. This time it is completely up and running. Now let's check the status related to Apache 2. You can see that it is up and running without any issue. Let's check the status of Mongodb as well. You can see that it is up and running. The reason why it is up and running is because we have enabled on reboots by using systemctl command. This is how we should be able to manage process associated with the applications using systemctl. Now, if you look at the help related to systemctl, there are other commands also. So far, we have used only status, reboot, but we have commands such as stop, start, etc. Sometimes we might want to perform certain maintenance of applications. If the application is supposed to be stopped at the time of maintenance, we typically use stop to stop. Once the maintenance is done, we will actually use start to start. Now let me come out of it. Keep in mind that whatever commands we are seeing here can be used using service as well. However, you prefer systemctl over service because systemctl is modern and service is legacy. Make sure you are really comfortable about systemctl command. It comes handy in many ways. As part of the section module, we are going through the details related to monitoring and managing Linux servers using system commands. So far, in that process, we have provisioned Ubuntu-based machine from AWS and then set up software such as Apache 2, Mongodb, etc. Apache 2 is an example for web server. Mongodb is an example for database. Already we have SSHD running on this machine. Due to SSHD only, we are able to connect to this via SSH. Now, in this lecture, let's go through the details about the services and also the components associated with the service. For each and every software we have installed so far, there is a service associated with it. For SSH, it is nothing but SSHD. For Apache 2, it is nothing but Apache 2. For MongoDB, it is nothing but MongoDB. A service is nothing but a process or a group of process. Also, there will be port numbers associated with the service. So there will be process, there will be port number, and also there will be quite a few configuration files as well as actual files associated with the service. If you take example of SSHD or Apache 2, there will be only configuration files. The actual files which contain something more than configurations will not be that relevant with these softwares. But when it comes to softwares such as MongoDB, which represent a database, on top of configuration files, we'll be having the actual data files as well. Let's go to the details so that you understand what I'm talking about here. First, I'll start with SSHD, then I'll go to the details related to Apache 2, then I'll be going to the details related to MongoDB as well. In this case, I'm already connected to the EC2 instance. You can see here. To check the status of SSHD, you should be able to use command called as sudo, then systemctl, then status, then sshd. You can hit enter. You can see that the SSHD server is running at this time on this machine. There are no issues with the service. Now, there should be a process associated with it. One of the ways to get the details related to the process is by using ps command. We'll be covering ps command in detail as part of subsequent lectures in this section. For now, remember that you should be able to use ps command and you should be able to get the details of process associated with the SSHD service. For this, you can actually run command called as ps-C, then SSHD. You can see the details about SSHD process. SSHD is a service. These are the processes associated with this service. You can also add F here to get some additional details. You can see you got the owner who owned the process, the process ID, parent process ID, so on and so forth. This is the main process associated with the SSHD. There are other processes as well. This is how you should be able to get the process level details for a given service that is set up on Ubuntu. Not only Ubuntu, but any Linux based server. That being said, the first thing is process. The second thing is port number. The port number associated with SSHD is nothing but 22. You can confirm that by using a command called as lsof. Even with respect to this command, you will be seeing quite a few details in the subsequent lectures. Keep in mind that you have to use sudo when you want to run lsof. So let me say sudo lsof. Then we have to use control arguments NA_P, then -C. For command, you have to specify the service name, which is nothing but SSHD. Using this, you should be able to get the port details by saying -I TCP, hit enter. You can see the details related to the port here. The port number associated with SSHD is nothing but 22. So we have gone through the details related to the processes associated with this service and also the port number. On top of these things, you also need to get the details about open files. To get the details about all the open files, again you can use the lsof command itself. In this case, when I say -i TCP, it is filtering for TCP details only. In case if you want to get all the details, you can just remove -i TCP. It will give you all the details, including all the files that are opened by this service. You can see all the files that are opened by this service at this time. Most of them are actually internal libraries. You can review these files to confirm. You can actually scroll up to actually go through all the files associated with this process or associated with this service. You can actually go through the details here. There are quite a few system files or internal library files which are being used by this process or service. Now let's go to the details about processes, port number, and also the files associated with Apache 2. First, we need to make sure we use systemctl to confirm whether the Apache 2 is up and running or not. For that purpose, we can say sudo systemctl status Apache 2. You can see that it is up and running without any issue. Now to get the details about the processes associated with Apache 2, you just have to say ps-f capital C Apache 2. Again, capital C is for the command. You should be able to see the process details associated with this service. There are 3 of them. You can see the details of all the 3 processes here. To get the port details, again you can use the lsof command which you have seen earlier. In this case, we have to replace SSHD with Apache 2. Then we'll be getting the port details associated with this service. You can see here the port number associated with this service is nothing but 80. If there are more ports, you will be seeing all the port details here. Now to get all the details associated with this service, especially from the files perspective, again we can use the lsof command. lsof stands for list open files. It will actually list all the open files associated with a process. In this case, we are actually getting details about all the process and also associated with the files with all the process related to Apache 2. You can actually go to the details here. This is related to error log. These are related to internal libraries associated with Apache 2, so on and so forth. On top of these things, when we actually talk about MongoDB, there will be database files also. First, let's see whether MongoDB is up and running. For that, we should be able to use systemctl command the way we have used earlier with SSHD as well as Apache 2. In this case, we have to replace Apache 2 with MongoD. Hit enter. You can see that MongoDB is running without any issue. You can get the port details about this service by using lsof command. We just have to replace Apache 2 with MongoD here. It will give us the port details. MongoD typically runs on 27017 unless we customize it. You can also see the host details here. It is running on localhost. Now let's also get all the details of open files by using same lsof command. I just have to remove -i TCP so that we get all the details. You can see all the details related to MongoDB here. On top of the configuration files, you can also see the files related to the actual data in MongoDB. You can review entries such as these. These are related to indexes and collections in MongoDB. All these files associated with the MongoDB data are under varlib MongoDB. You can also review the details by saying sudo ls-ltr varlib MongoDB to get all the files and folders associated with MongoDB, especially from the database perspective. On top of the files related to collections and indexes, we also have log file and many other things. This is how you should be able to reverse engineer any service and understand all the components related to that service using commands such as ps and lsof. As we got an overview about services and also processes, port numbers, and files associated with these services, now it is time for us to explore commands such as ps, lsof, and others in detail. Let's go through those in subsequent lectures in the sectional module. As part of the sectional module, we are going through the details about monitoring and managing Linux servers using system commands. Typically, we monitor and manage the applications from the perspective of memory, CPU, storage, etc. First, let's recap the commands which can be used to get details about the Linux servers such as memory, CPU, storage. Then we'll actually go to the details related to the commands which can be used from the application perspective. Also, as I have set up Linux using WSL on Windows, first I would like to review the details about the computer used using Windows Task Manager, then I'll actually get into the details about the basic commands that can be used to get the Linux server details. To get the details about your Windows machine, you should be able to go to the search bar. As part of the search bar, you should be able to search for Task Manager. You can click on the Task Manager. If you get into this window, you can click on this to get more details. To get details about your memory, CPU, storage, etc., you can go to the performance. You can see the CPU details here. This system have only one CPU. However, it's a dual core CPU. That's why cores is 2. The logical process are nothing but 4. When it comes to the memory, we have 16 GB memory, out of which 4 is being used at this time. The remaining is available. You can also get the details related to the storage. Out of 128 GB storage, whatever storage is used should be displayed somewhere. Let me see if it actually provides details here. Capacity 127 GB, formatted 127 GB. However, it doesn't talk about available storage. To get the available storage, you can actually go to the File Explorer. Then you should be able to go to this PC. You can actually see the details here. Out of 128 GB, 75 GB is free. Now let's go to the details about how to get these details on Linux. In this case, I'm in the EC2 instance that is provisioned from AWS. Let me exit from here. Actually, it is hung. I came out of it by hitting shift and then tilde and then dot. It will actually come out of the hung session. Now I'm in the Ubuntu. I should be able to use commands such as lscpu to get the CPU details. You can see the CPU details here. Let me scroll up here. When it comes to CPUs, it says 4. It is because on the host, we have 4 virtual processors. That's why you are seeing 4 here. The same number what we have seen on Windows is visible here because this is set up on top of Windows itself. Then we should be able to use free-h to get the memory details. Out of 16 GB, only 8 GB is allocated to this virtual machine. Out of the 8 GB, 7.2 GB is free, 7.3 GB is available. There is a shared or cache memory which can be reused. That's why it is saying 7.3 GB when it comes to the available. Actual used memory is nothing but 221 MB. This is how you should be able to get the memory details. We have gone through the details related to CPU and memory. To get the storage details, you should be able to use df space -h and hit enter. You should be able to get the storage details. On this machine, it is actually showing as if we have 256 GB or 251 GB. Out of that, 16 GB is used, 223 GB is available. Also, you can see here, it says 127 GB, out of which 53 is used and 75 GB is available. I'm not sure from where this 251 GB coming into picture. Don't worry too much about it. As I am using Ubuntu on top of Windows using WSL, it might be providing this information as a default. Even if you don't understand or even if it is not clear, you don't need to worry too much about it. The main mount point is nothing but this one. You should be able to review the storage here. Whatever we have seen as part of Windows, the same storage is visible even here. You can see here. This is how you should be able to get details related to memory, CPU and storage on Ubuntu based servers. Let's also connect EC2 instance which we have provisioned from AWS. Let's run lscpu command first. You can see the CPU details here. Let's see how many CPUs we have. In this case, we have only 2 CPUs because we have used t2.medium, which actually gives us 2 virtual CPUs. Then when it comes to the memory, you can use -h. You can actually see the memory details here. Total memory is 3.8 GB, out of which only 221 MB is being used at this time. 3.4 GB is totally available. The actual free memory is 3.1 GB only. Now let's use df-h to get the storage details. The root mount point only have 7.7 GB of storage. When I have actually set up this machine, I haven't increased the size of the hard drive. That's why it is only having 8 GB storage. This is how we should be able to review the details related to our Linux server using commands such as lscpu, free and df. Make sure you remember these commands as and when we explore the commands related to monitoring and managing applications and databases on Linux servers using certain commands. We need to make sure we evaluate the output against these resources at the server level. All the resources of our application and database should be within the limits that are at the server level. The server level can be retrieved using the commands which I have gone through. That being said, as we have understood how to get Linux server details, now it is time for us to understand more details from the perspective of troubleshooting the issues. We'll start with the uptime command and then we'll actually take it further. As part of this section module, we are going through the details related to monitoring and managing Linux servers using system commands. As part of the previous lecture, we have gone through the details about basic commands to get Linux server details such as CPU, memory, storage, etc. Now it is time for us to understand how to use command called as uptime to get CPU or load average. As we install more and more applications and databases onto a server, over a period of time, the CPU usage will go up and down. We should be able to get the average details using a command called as uptime. Let's review the help related to uptime by saying uptime space -- help. Uptime is a very simple command. However, it gives very important details with respect to the computer. It is nothing but CPU. You can actually say man uptime to get the man page of uptime. When it comes to uptime, it tells us how long the system has been running. You will see the CPU details as part of the output while conveying how long the system has been running. You can come out of this, you can run uptime. This is the current time. As of now, it is saying the server is up. As of now, it is up for 1 hour 11 minutes. There are 2 users logged into the system at this time. Then comes the load average. The load average is given in minute, in hour, and in day. You should compare this information with the number of CPUs. We can actually get the number of CPUs by using lscpu command. It is supposed to be lscpu, not lscpur. Now, if you scroll up and review the number of CPUs, this machine have 2 CPUs. As long as the CPU average is less than 2, we are in a decent shape. However, it should be close to 60 or 70% of the number of CPUs. It should not be 0, which means we have over-allocated the system for the applications which are supposed to be running on this machine. This is how you should be able to use uptime and compare with lscpu and see how efficiently your system is running. Keep in mind that the average should not be considered as percentages. Make sure you compare this with the number of CPUs we have. Now you can see the current time. The state is up. It is up for 1 hour 13 minutes. You can also use uptime -p. It will actually give us the details about the duration for which the server is up and running at this time. It is up and running for 1 hour 13 minutes. You can also use uptime -s. It will actually give you the details about when the server is actually started. These are the options which we have with uptime. It's a very simple command but very effective when it comes to giving us the details related to the CPU, and hence make sure you are familiar with it. Now let me exit from here. Now I am in the Ubuntu which is set up on top of Windows using WSL. Let's say uptime and review the output here. You can see the details here. As of now, it is up for 2 hours 50 minutes. You can see the details. This is the time which is current time. You can also see that there are no users logged into the system. I don't know why it is saying 0 users. Again, this is set up using WSL on Windows, and hence the output will be a little bit tricky compared to direct Ubuntu system. When it comes to the load average, you can see the load average here. It is 0.02. However, we have 4 CPUs on this machine. You can confirm by running lscpu command here. Let me scroll up. You can see the number of CPUs we have. This is how you should be able to use uptime to get the CPU or load average of your Linux-based server. As part of this section module, we are going through the details related to monitoring and managing Linux servers using system commands. In this lecture, let's get an overview of ps command to get details about process on Linux server. We'll limit the scope to get helper usage as well as man page related to ps command. To get helper usage, we can say ps space -- help. You can actually see basic information related to ps command. ps is robust command, and hence they have categorized into simple, list, output, threads, or miscellaneous, all. These are the categories using which we should be able to get details about control arguments to control the behavior of ps command. For example, if you want to understand all the control arguments related to output of ps command, you can actually say ps space -- help, then space either output or o. Let's give a try. In this case, I'm saying ps space -- help, then space o or output. Either of them will give the same output. You can see the options which actually control the behavior of providing the output with respect to ps command, along with the other options we typically use. In the similar manner, we have other options. You can actually get all the control arguments using all. In this case, you have to say ps space -- help, then either a or all. It will give all the options related to ps command. You can see that it have provided a lot more details this time. Whatever you are seeing now are related to output formats. You can also go up and see other categories. This is simple or basic. This is related to a list, I guess. We have a simple list, then output. Then we also have miscellaneous or M. After output, you can see the options related to miscellaneous or M. You can see here. We also have threads or T. You can actually get these options when we use T or threads. And we have used all. When we use all or A, you will actually see the details of all the control arguments that are available on top of PS command. If you want to get complete documentation with respect to PS command, you have to say man PS. Then you should be able to get complete documentation related to PS command. Once you are in the man page, you should be able to hit J to go down, or you can also say Control F to go down one page at a time. If you want to go one line at a time, you can use K, or you can use Control B. Make sure you are familiar about these commands. In this case, as part of the man page, you can hit J to go one line down at a time. You can use K to go one line up at a time. You can then use Control F to go one page forward at a time, or Control B to go one page backward at a time. If you want to come out of it, you just have to say Q. You will be coming out of this man page. Make sure you are familiar with these commands so that you can navigate through the man page which you get when you run man ps command. Now let's review the man page once again. You can hit Ctrl F to move forward one page at a time. You can see the commands which we typically use. You can actually see every process on the system using -e. However, if you want to see as many details as you want, you can play with F or capital F or LY. It will actually provide you details related to each and every process on the system. You can run these commands and see the behavior. In the similar manner, they have given quite a few commonly used examples. You can hit Ctrl F here and move forward. You can see there are at least 15 to 20 PS variations. You can experiment with these commands and understand what they are actually doing. That being said, we'll be seeing some of the common examples and I'll be explaining the output in details. Make sure you spend enough time to understand PS command better based upon the role you are going to play as part of the organization while supporting the applications on Linux servers. Let's run ps-e and ps-ef and see what happens. We'll actually go through quite a lot of details about these important commands as part of the next lecture. However, before moving on to the next lecture, let's run ps-e as well as ps-ef by coming out of this man page. To come out of the man page, you can always hit Q and you will be able to come out of the man page. Now you can actually say ps space -e and see what happens. It have only provided details related to PID, TTY, time, CMD, etc. However, if you use ps-ef or ps-e capital F, you can see that it is giving a bit more details than what we are seeing with only ps-e. These are the basic differences between these commands. However, you might not be familiar about what these details are. We'll go to those details as part of the next lecture. As you got a brief overview of PS command in the previous lecture, let's understand how to use it to get details of all the process running on Linux server. The basic usage with respect to PS command to get details of all the servers is nothing but ps space -e. You can hit enter and you can see the details of the process that are running at this time. If you actually say ps-e, then pipe more. You can also see the header. When it comes to the header, you can see that we have columns such as PID, which stands for process ID, TTY, time, and CMD. CMD stands for command. If you want to understand the meaning of these columns, you can actually go to the man page and go to relevant section to see what TTY time means. CMD means command, PID means process ID. For each and every process that is running on Linux server, there will be a process ID. You can actually review the process ID from here. It is very, very important for you to understand the process ID. We might use this process ID to kill in case if we think the process is not required anymore. Make sure you understand the relevance of process ID. If not now, by the time you actually complete this section, you should be comfortable with respect to process ID. Now let me hit Ctrl C to come out of it. To get details with respect to columns such as TTY, time, etc., we can go to man page of PS by saying man PS. Then we should be able to search for TTY like this. As TTY is in uppercase, we should be able to search for it. You can say N to actually go to next TTY. We'll go to the place where they have explained details related to TTY. We are almost there. You can see here. TTY is nothing but terminal. So if there are any sessions using terminal, for them there won't be question mark, otherwise you will see question mark. Let me hit Ctrl C here, or let me hit Q to come out of this man page. Now let me run ps-ef more. You can see that there are question marks for most of the commands because these are not related to terminal. You can hit space like this to move forward, and you can see there are few things where there is no question mark, which means they are related to the terminal. You can review last 3 processes. These are related to the command which I have ran earlier. It is nothing but ps-e more. That's why you are seeing one process related to ps command, another process related to more. As these are submitted through terminal, you can see a non-question mark here. This is how you should be able to interpret TTY. Now let's review the details with respect to time. Again, we have to go back to the man page here. This time we have to search for time all in capital. This is one of the column which we have seen when we actually say ps-e. Let me search for time. You can continue searching until you get to this section. You have to hit N to move forward until you come here. If you review the details related to the time, it is nothing but BSD time. Also, it is accumulated CPU time. It includes user as well as system time. This is how you can actually interpret time. If you want to go to this section to review all the column details, once you get into the man page, you just have to hit Ctrl F until you go to the section where they have provided descriptions for all the columns which are relevant to PS. You have to hit Ctrl F quite a few times until you go to that section. Now I have come to the section in man page where it talks about code, header and description. This is where you should be able to review the details with respect to each and every column you typically see as part of PS commands. Based upon the command you use, you will see these names as part of the columns. It can be %CPU, %mem, command or CMD, blocked, start, time, capital C, cot, cgname, co-group, so and so forth. You can actually go through this documentation to understand what they actually mean. Now let me come out of this. For that I can hit Q and come out of it. Now let me say ps space -ef, then say pipe more. Now let's review the details. On top of PID, time, CMD, we are actually seeing additional details. We are seeing UID, PPID, C, S time, TTY is seen even before. The additional columns are nothing but UID for user ID, PPID for parent process ID, C for %CPU. C is the shortcut for %CPU which we have seen earlier. S time we need to review to understand what it is all about. Let's go to the documentation and understand these additional columns which are not very obvious for us. Let me hit Q to come out of it, or you can also hit Ctrl C. Now we should be able to say man ps, then hit Ctrl F until we get the section where we have the documentation related to all the columns. Then let's go through C. You can see the details with respect to C. They're asking us to review %CPU. This is nothing but shorthand for %CPU. On top of it, we also need to review S time. We are not sure about S time. Others are quite obvious. PPID is for parent process ID. UID is for user ID. However, when it comes to S time, we are not 100% sure. Let's go to the place where we have details related to S time to understand what it is about. It is not actually showing details with respect to S time. We can search for it. Let's say S time like this. Let's come out of it. Let's go into man page once again. Then let's search for S time. And there is no documentation with respect to S time. Let's search for lowercase s time to see if there is any information. Yeah, you can see the details with respect to S time here. However, it is saying cumulative system time. Probably S time means system time. I'm not 100% sure. Yeah, now you can see here. S time is nothing but start time, not cumulative system time. This is how you should be able to interpret the columns that are displayed when we actually run commands such as ps or ps-ef. Now we will also see details related to ps-e capital F. Typically, these are the commands which we use to get details with respect to all the processes that are running at this time. Let me come out of this. Let's run ps-e capital F and see what additional columns we get with capital F. Again, let me use pipe more to review the header. You can see more columns here. We can see details such as SZ, RSS, PSR, These are the ones which are not visible earlier, but now they are visible. You need to understand what these are about. These are related to the memory. SZ stands for size. I'm not 100% sure about RSS and PSR. You can actually go to the documentation and understand. Let me hit Q to quit, and then let me go to man page. Let me search for RSS. RSS is for RSS size. You can also search the documentation related to RSS size where you might see additional details. Let's see where we have details related to RSS size. Yeah, this is where you have details with respect to RSS. It is nothing but resident set size, the non-swapped physical memory that a task has used. So this is the information related to the physical memory that is used by a particular process. RSS is related to the physical memory. The other column which we have seen is nothing but PSR. Let's go to the details related to PSR, and also we need to review SZ. Let's come out of this. Let's go to man page. Let's search for SZ or SZ. Let me search for capital SZ. Let me search for small sz. Most likely SZ should be shortcut for VSZ only. VSZ stands for virtual memory size, but I am not 100% sure. Let's also review the details related to PSR to understand what it is about. Let me come out of it. Let me go to the man page once again. Then let me search for PSR. PSR is nothing but processor that process is currently assigned to. You have multiple processors as part of your computer. PSR will give you the details about which processor the current process is assigned to. Now let's come out of this, then go to PS space -e capital F, then pipe more. One of the columns is nothing but PSR. You can see zeros and ones here. The reason why we are only seeing zeros and ones is because we have two CPU machine. That's why we are only seeing zeros and ones here. Let's come out of this, then run lscpu command. If you review the output here, you can see that the system on which we are actually experimenting have only two CPUs. That's why we're only seeing zeros and ones with respect to the process that are running on this system. This is how you should be able to use PS-E with variations such as F and capital F to get details about all the processes that are running at this time on the computer. It is one of the most frequently used PS command. You should be familiar about it. As we have understood how to use PS command to get details of all the process running on Linux server, now it is time for us to list the process owned by a specific user. For that purpose, we can use PS-U. If you say PS-U, it will actually give us the details about the process owned by a specific user. When it comes to the output, it is actually providing the details related to the user, process ID, percentage CPU or C, this one and this one are same. Then percentage memory, VSZ, RSS, TTY, stat. We haven't explored what stat actually mean. If you want, you can actually explore by going through man page of PS command. I will not be doing that. Start is nothing but start time. We also have time, which is nothing but cumulative time with respect to CPU. Then the command. Except stat, we have already reviewed all these columns earlier. Even though we haven't reviewed percentage mem earlier, it is obvious from the name. That being said, there are other variations with respect to PS-U. The first one is nothing but F or FU. We typically use -FU than UF, but whether you use UF or FU, it will actually give the same details. Now, if you look at this, this also gave the same output. Only thing is, as part of the output, it have actually provided the details in the tree format, which emphasizes that this is a child process to this one. Now, let's try PS-UF. Even this one should give the same details. You can see here, even this one actually have given the same details to us. While PS-E gives us details about all the processes that are running on a specific Linux server, PS-U will be giving us the details about processes that are owned by specific user. By default, we'll be getting details related to the process owned by logged in user. We should be able to use PS-U to get details about process run by other users as well. In this case, I can say PS-UF or FU. Typically, we use FU. Then we should be able to specify the user. Let's say root. There will be root user on each and every Linux machine, and hence we should be able to validate using root like this. You can see the process that are owned by root. Even though I am logged in as this user, I am able to pass the username like this, and I am able to get the process that are owned by this user. Let's also connect to the remote machine and see how it actually works when we have full-blown Ubuntu. As of now, I'm using Ubuntu that is set up using WSL. This is not a complete Ubuntu, and hence the process which you are seeing are limited. But if you actually log in into a full-blown Ubuntu-based machine, then you'll be seeing a lot more details. So in this case, let me actually connect it to the machine which I have connected earlier. That machine is provisioned from AWS. This is the one which I have provisioned. Let me hit enter. I'll be able to log in into that machine. Once login, we can actually say ps-fu. It will give us the process that are owned by Ubuntu. You can see here. I can also get the details about the process owned by root here. You will see a lot more process here. You can also use capital F rather than small f. Let's say capital F, and let's see what it actually gives. Let's remove the root user. Then run it. You can see that it is failing. When we use capital F, we have to specify the user. When we say ps-fu, you can see that we are able to see the process owned by the logged in user Ubuntu. However, when we use ps-fu, it is failing. If we pass the username like this, then it should work. You can see that it is actually giving us a bit more details than what we have seen with small fu. However, all the processes are actually owned by user Ubuntu only. Let me run ps-small fu once again. You can see that it is only showing 2 of them, but with the capital F, we are actually seeing more details. You can actually go to the documentation about using capital F along with U and understand why it is actually providing a bit more details than what we have seen with just small fu. This is how you should be able to get details about the process owned by a specific user. You can optionally pass username like this. If you don't pass the username, then it will actually give us the details about the process that are owned by the logged in user. In this case, it is nothing but Ubuntu. We have seen quite a few variations related to ps-e as well as -u. All the variations have actually given the output with predefined criteria. We should be able to customize the output. We'll see how to customize the output while running these commands as part of the next lecture. As part of previous 2 lectures, we have gone through details related to ps-e and ps-u to get details about the process that are running on a Linux server. However, the output is seen based upon the predefined criteria. In this lecture, let's go to the details about how to customize the output while running these commands. If you recollect, if I say ps-e, it actually gives details about all the processes that are running on this machine. However, it only gives details about few fields. Let's pipe this to more and see the output. You can see that it is actually giving the output related to process ID, TTY, cumulative CPU time, and command. Now, if you want to get some other columns than these, let's say I would like to get only PID and CMD. I don't want to get the details related to TTY and time. Then we need to understand how to customize the output. For that, we have to use -o control argument, and we should be able to customize the output. Let me say Q to come out of this. Now, let me say ps-e, then -o. In this case, I just want to get PID and CMD. Now let me hit enter. However, it did not work as expected. Let me use lowercase PID and CMD. Most likely it should work. I can say PID, CMD. Now you can see the output. Let me exit from here. I came out from the remote Ubuntu based machine onto the local machine which is set up using WSL on Windows. The reason why I came out is if I run ps command here, I'll be seeing lesser output compared to what I'm seeing on the remote machine. That's why I came out. Now let me say ps-e, then /o, PID, CMD. You should be able to see only PID and command. Others are discarded. Like this, you should be able to customize by specifying the fields you want to review using -o option. Let's go to the man page of PS. There is a section where it actually gives us details about all the columns that can be passed. Let's go to relevant section. You can also see a few examples here. You can say ps-eo, then PID, TID, class, RT, prior, so on and so forth. All these details will be printed as part of the output. This is one of the variations of ps-e command with O. Like this, you can explore all the column names that can be passed, and you should be able to specify the column names and get the output for the fields you are looking for. You can also use shorthand columns. Let's review the column names, and I will actually demonstrate how to use shorthand columns also. Now let me hit Ctrl F to move forward. We need to go to the section where they have specified details related to these columns. Probably these might work. You can see key, long is CMD, Let's review the details about this here. These are obsolete sort keys. These are related to sorting. Let's ignore this and move forward. You can see here the code is %C, %G, %B, so on and so forth. So either you can use these codes or you can actually use these normal column names. Let's come out of this. Let's review the details about PID and command, and we'll be using the codes instead of column names. For PID it is %p. For command it is nothing but %c. So in this case, we should be able to come out of it. Then we can actually say ps-e-o or ps-eo. You can use either of the approach. Then you can actually say %p, then comma %c. You can see the details here. Because we have specified comma here, it is actually showing comma here. We can replace the comma with the empty string. You can see the output. This is how you should be able to specify the column names and customize the output. This will work not only with the -e but also with -u, where we actually get the details about the process owned by specific user. So in this case, I can say ps-fuo, then %p, %c, the username, let's say dgadiraju. Let's hit enter. However, it did not work. The reason why it did not work is we have to specify the details like this. We have to say ps-u, then dgadiraju, then -o, then %p, then %c, hit enter. Now you can actually see the details as per our expectations. This is how you should be able to customize the output. This gives us a lot more flexibility with respect to automation. You can also go through ps-help with these options, and you should be able to see different options we have to customize the output when we actually run these commands. Make sure you spend enough time on PS and be comfortable with it. It comes very handy when it comes to troubleshooting complex issues. Yeah, we have gone through quite a few details with respect to PS command. In this lecture, let's understand how to come up with a one-liner where we'll be piping the output of PS command to other commands to get number of processes on Linux server owned by each user. For that, I'll be using my own lab. I'll not be using either AWS EC2 Instance or the Ubuntu based machine. However, you should be able to experiment whatever I'm demonstrating here on any server for which you have access to. In this case, I'll be connecting to my lab through my terminal on Mac. Now let me say g01.itversity.com. This is my lab. If you have access to any server in your organization, you should be able to log in into that server, and you should be able to come up with the logic to get number of processes owned by each user. We should be able to use ps-e command to get all the processes that are running on this machine at this time. You can see that there are quite a few processes that are running at this time. However, when it comes to the output only contains process ID, TTY, time, and command. When it comes to time, it is nothing but cumulative CPU, system time, as well as user time. Now, I would like to get the user details so that I can actually get the number of processes owned by user. For that, I have to use ps-ef variation. So instead of saying ps-e, let me add f. Let's pipe and say more. Hit enter. We can see the output here. You can see UID, PID, so on and so forth. You can actually see the usernames here. However, when it comes to the usernames, they are not complete. You can see here there is a plus here, which means we will not be able to use these usernames to get the number of processes owned by each user. We have to get complete username. For that, we can use -o, which actually facilitates us to customize the output. When we use -o, we can actually discard the rest of the columns, and we can only specify whatever column we want. In this case, it is nothing but username. Even though when we actually use ps-ef command, the first column is UID. If you try to use UID as part of ps-eo command, we'll be seeing incorrect details. In this case, I'm saying ps-eo, then pipe, then more. As part of the O, let me specify UID. Now, if I hit enter, you see it is actually giving us the user IDs, not the usernames. To get the usernames instead of user IDs, we have to use user, not UID. So in this case, I can say user. Now we should be able to get the details about usernames here. Rest of the details are ignored. This time the usernames are complete. Now let me remove the more. Let me run it. We should be able to see all the usernames here. Each line actually represents one process ID. As we have discarded rest of the information, we are only getting the user IDs. Now we should be able to pipe the output of this command to sort. The data will be sorted. You can see here all the details are sorted. Now we should be able to say pipe unique -c. Now you can see the output where we got the count of process owned by each user. However, the output is not sorted. To sort this output again, we can actually say pipe, then sort. However, the output might not be sorted numerically. To make sure the output is sorted numerically, we can actually say -n. Now you can review the output. The output is sorted based on the count of process owned by specific user. Root is the user which owns most number of process. Now if you wanted to sort the data in reverse order, you can actually say -nr here. The output will be sorted in reverse order. You can see the root at the top. Discarding root, Postgres is the user which owns most number of process. It owns 55 process. This is how you should be able to leverage the skills acquired over a period of time to use a combination of commands to get the details you are looking for in accelerated manner. In this case, we have gone to the details related to getting the count for each user. We can also get count for each processor and many other variations. You can also get count based on command. You name it, you should be able to come up with the solution. Let's also go to the details about how to get the count of process that are associated with a given processor. First, let's understand how many process this machine have. For that, I'm actually using lscpu command. You can see that I have 12 CPUs on this machine. The numbers are nothing but 0 to 11. Now, in this case, I can actually go up to this command where I'm saying ps-eo user. Then I can replace user with PSR. PSR stands for processor. Using this simple technique, I should be able to get number of process associated with each processor. You can review the output here. The output is sorted based on the count for each processor. Processor 5 have 181 process, processor 10 have 130 of them. You can review the output. The data is sorted in reverse order by count. You can ignore this one. This is related to the column. That's why it is saying 1 with respect to PSR. This is how you should be able to use ps command with other commands to get the details you are looking for in accelerated manner. Make sure you are comfortable with not only related to ps command but also the other important commands in Linux. As part of this sectional module, we are going through the details related to monitoring and managing Linux servers using system commands. At this time, we are actually talking about a very important command. It is nothing but ps. ps actually gives us the details about the process running on Linux server. Already we have seen how to get list of process owned by specific user and also how to get details of all the process running on Linux server. Now it is time for us to get the details about the process that are associated with a given application or database that is running on Linux. I have provisioned EC2 instance from AWS with Ubuntu 20.04 operating system. Once it is provisioned, I have even installed Apache 2 as well as MongoDB on it. Let's go to the details about how to get the process associated with these applications. They are nothing but Apache 2, MongoDB. MongoDB is also an application. It is a database application. On top of these two, we already have SSHD, which is available out of the box. Now let's review the status of these three applications or databases. Then we'll actually go to the details about how to get the process IDs and other information associated with this process. In this case, I am in the session which is connected to the EC2 instance on AWS. Let me make sure that it is active. It is active. To confirm whether SSHD is up and running or not, we should be able to say sudo systemctl, then status SSHD. I have already covered the details with respect to systemctl as part of the earlier lectures. You should be able to leverage that knowledge and you should be able to check the status of SSHD. As of now, you can see that it is running. If it is stuck like this, you can hit Q to come out of it. Now, if you want to get details about Apache, you can actually say systemctl status Apache 2. You can see that it is running. Even we can check the status of MongoDB. The process name is nothing but MongoD, and hence we have to say MongoD like this. As we have successfully validated SSHD, Apache 2 and MongoD, let's understand how to get process details about these services that are running at this time. For that, we can use ps command. One of the rudimentary way of getting the details is using ps-ef. Then by saying grep, we can actually pass the service name. It can be MongoD or Apache 2 or SSHD. We should be able to get details of those processes that are associated with the services. You can see the details related to MongoDB. But this is a little bit amateur way of getting the details. As long as we know the actual command that is being used, in this case MongoD, we should be able to use variation of ps command to get the process details of the service. In this case, we are attempting to get the details of process associated with service using a command, and hence we can actually say ps-help space a. It will actually list all the control arguments that can be passed to ps. To limit the scope to command, we can actually pipe then say grep-i command, hit enter. We should be able to see the details with respect to the arguments which have command in them. In this case, we should be able to use -C and pass the command name to get the process details associated with a particular service. Let's see an example so that you are clear about it. I'm actually saying ps-C, then sshd. SSHD is the command which is actually running the SSHD service, and hence I have passed SSHD here. You can see the details here. However, we are not sure about who is the owner of this process, and also we are not clear about what is the parent ID and what is the child process ID. To get all those details, instead of saying ps-C, we can actually say ps-F C. Order matters here because we have to pass command as an argument, and hence we have to say ps-F and then the command. It should work without any issues. If you say ps-CF, it will not work. You need to make sure the order is F and then C. Now you can actually see the details. The actual process ID with respect to SSHD is nothing but 702. You can confirm by reviewing the details under CMD. This is the command which actually starts the SSHD daemon process. If you observe, 702 is the main process ID associated with SSHD. All the other process IDs are either child process IDs or grandchild process IDs. If you see this one and this one, these are child process to 702. When it comes to this one, this is child process to 39786, which is nothing but this one. Even this one is child process to this one. This is how you should be able to get all the process details for a given service using ps-F, then C. Then you can actually pass the command associated with the service. You can also give a try by using Apache 2 in place of SSHD. Let me say Apache 2 here. You can review the output and you can confirm that these are the processes that are associated with Apache 2. The main process is nothing but this one. The process ID is 520. It is owned by user root. The other two processes are actually child processes for 520. If you are interested, you can also run this command against Mongodb and see what details it provides. You can review and go through the output to improve your understanding associated with ps-F C command. That being said, this is also a very important variation of ps command, and hence make sure you understand it so that you can use it as and when it is required. As part of this section module, we are going through the details related to monitoring and managing Linux servers using system commands. In the past few lectures, we have gone through details related to ps command, which actually provide us the details for the process associated with a Linux server. Now it is time for us to explore another important command, which is nothing but lsof. lsof stands for list open files. We can get the usage of lsof command by saying lsof-h. It will give us the usage of this command. You can see that there are quite a few control arguments with respect to lsof. But to get started, you can actually focus on arguments such as -c for command, -p for process ID. Also, there is a way to get a list of open files based on port. I'll be demonstrating as part of the next lecture. lsof-h is the command to get the usage of lsof command. You can also say --help, but --help will actually give us error at the top. -h is more appropriate to get the usage of lsof command. To read the documentation and understand the control arguments based on your requirements, you can always go to the man page. You can say man lsof. You should be able to review the details. You can see the description of this command. It is primarily to list open files. You can see all the control arguments that are supported with lsof. You can also review the description of control arguments related to lsof. I have already mentioned about C. C is for command. You can read. Selects the listing of files for process executing the command that begins with the characters of C. You can also see an example by saying lsof-c. Let's say sshd. Hit enter. You can see the list of files associated with sshd. However, there are issues such as permission denied here because we haven't used sudo. Instead of saying lsof-c sshd, if we say sudo lsof-c sshd, you can actually see the details without any errors. There are quite a few open files associated with sshd. This is how you can get started with lsof command. Now, before going to the tasks associated with lsof command, let's understand the current state of this machine. This machine which I have connected to is from AWS. Once I have provisioned this instance from AWS, I have even set up additional softwares in it. They are nothing but Apache 2 and Mongodb. SSHD is available out of the box. The operating system that is used to provision these EC2 instances is nothing but Ubuntu with 20.04. We have already reviewed lsof command against sshd by using -c. We can also get a list of open files associated with Apache 2 as well as MongoDB by using a similar approach. So in this case, I can actually say lsof -c, then Apache 2. Let's make sure we add sudo at the beginning, because some of the files might be owned by root user. To get details about those files which are owned by root user, it is better to use sudo. You can see the output here. There are quite a few open files associated with Apache 2. In the similar manner, we can also validate using MongoDB here. We just have to specify the command, which is nothing but MongoDB for MongoDB. You can see the details about open files associated with MongoDB. This is how you should be able to get details about the open files using lsof-c command based on the command. We can also pass process ID, port number, etc. and we should be able to get the details of open files based on process ID, port, etc. We will see few examples as part of the next lecture. We will be using the same applications and databases that are set up on this machine to explore lsof command using process ID and also port number. Let's go to those details in the next lecture. As part of the previous lecture, we have got an overview of lsof command to get list of open files on Linux. In this lecture, let's understand how to use lsof to get open file details based on process ID. First, we need to identify the process ID associated with the service. Then we have to take it further. We should be able to use ps-c command to get process ID details. Once we get process ID, it is pretty straightforward to use lsof to get list of open files based on the process ID. First, let's explore how to get process ID once again using the steps which we have taken earlier. It is nothing but systemctl to validate whether the service is up and running or not. Once we understand the service name, we can pass it as a command as part of ps-c, and we should be able to get the process details for that command or service. To confirm, we can actually say sudo systemctl, then status. Then we can actually specify the service name. It can be sshd or Apache 2, because we have 3 of them running on this machine. They are nothing but sshd, Apache 2 and also MongoDB. You can see that all 3 of them are running without any issues. Using sshd or Apache 2 or MongoDB, we should be able to use ps-c. Then we should be able to specify the command. Let's say I would like to see the process details for Apache 2. I can use Apache 2 like this. I should be able to get the process details here. Out of these processes, the most important one is nothing but this one. It is owned by root. The process ID is nothing but 520. If you look at the other 2 processes, this is the parent process for those 2. And hence, this is the one which we can pick and then we can take it further. Now, to get a list of open files based on process ID, we should be able to say sudo lsof-p for process ID. Then we have to specify the process ID, which is nothing but 520. You can see all the details with respect to process ID 520. These are the open files associated with process ID 520. Let's run ps-f-c command once again against Apache 2. Now let's validate lsof command using process ID 38985 or 38986. In this case, I'll be using 38985. Let's hit enter. You can see all the details with respect to this process ID as well. This is how you should be able to get the open file details based on process ID. If you want to filter, you should be able to filter. For example, in this case, if you want to just get details about TCP, then you just have to say lsof-p 38985, then -i TCP, hit enter. However, it is actually getting all the details. We also need to add one more thing here, -na, then hit enter. Now you can actually see the details associated with only the ports or networking. Even this one is considered as an open file. That's why it is listing even these details. In case if you want to get details about the port numbers, this is how you can get. By default, it is actually giving us the name of the port rather than the port number itself. To get the port numbers rather than the names, you should be able to add capital P here. Then you should be able to get the actual port numbers. You can see the 80 as the port number associated with this process as well. So for all those processes related to Apache 2 service, the port number is the same. In this manner, you should be able to get details with respect to SSHD or MongoDB as well. I'll be demonstrating using MongoDB as well. You take SSHD as exercise and explore the same details. To get the process details associated with MongoDB service, you just have to say ps-f capital C, then MongoDB. You should be able to get process details. The process ID for MongoDB service is 458. There's only one process. There are no other process. In this case, it is a little bit straightforward compared to Apache 2 or SSHD. For Apache 2 or SSHD, you might see additional process. Once you get the process ID, then you should be able to use sudo lsof, then -p, then process ID, which is nothing but 458. You can get details about all the open files. In case if you want to get the details about TCP, you can actually improvise on top of it by saying -i TCP. Also, you need to add this additional argument. It is nothing but -NA capital P. Now you should be able to get the port details associated with process ID 458. Process ID 458 is ID of a process associated with the service called as MongoDB. Now let's go through the details about all these control arguments. NA capital P, -P and -I. We are using 5 control arguments. To get the details about these control arguments, we should be able to see the usage. To get the usage details, we can actually say lsof -h. You can actually see all the details about all the control arguments here. We are using -p. You can see here we should be able to get details about open files by passing PIDs or process IDs using -p. On top of it, we have also used -i. -i is typically used to actually filter based upon some network information. In this case, we have said -i TCP. It have given details about only those open files associated with TCP. That is the purpose of -i. We have already gone through the details about -p. Now it is time for us to explore -a, -n and -P. -P is to give the port numbers rather than the names. When it comes to -n, it is to give us the IP addresses rather than the host names. -a is the end operator. The main reason why the details are filtered only for TCP is because of -a. Now let me go back to this command. Let me remove capital P and N and see what happens. Still we got the details about the TCP only associated with the process ID 458. However, if you look at the name, it is saying localhost. When it comes to the port number, it is saying 27017. Now, instead of using this for the process associated with MongoDB, in case if I want to get for the process associated with Apache 2, I should be able to improvise this command by saying lsof -a, then -c. In this case, I'm passing the command details rather than process ID. If you want, you can get the process ID associated with Apache 2 and you can take it further. Now let me hit enter. You can see the TCP details associated with Apache 2 service. There are 3 processes, 520, 38985 and 38986. All of them have name like this. Star represents the host name. HTTP is nothing but port protocol name. Now, if I use capital P rather than just -a like this, instead of getting the names associated with the port protocols, we'll be getting actual port numbers. That is the purpose of capital P. If you want to get port numbers, you have to use capital P like this. Otherwise, you'll not be getting the port numbers. However, this might not be applicable for MongoDB because there is no standard name for the MongoDB port. That's why when we use -a capital P with -p 458, this process ID is associated with MongoDB. In this case, it is still saying 27017. So capital P is primarily to replace port protocol names with actual port numbers. It is applicable primarily with standard protocols such as HTTP, SSH, etc. You can also experiment with SSHD here. You can see all the details here. Now let me remove capital P and see what happens. When it comes to the port details, it is actually giving us the port numbers. Now if I remove capital P, it is actually giving the port protocol name, which is nothing but SSH because it is standard. Now let's explore the details related to N. By default, when we use only -a to filter whatever we are looking for, wherever the host names are relevant, it is actually giving the names like this. You can see here. This is related to SSH. Even with respect to MongoDB also, the names are printed with respect to hosts. In case if you want to replace names with IP addresses, then you have to add n. It will take care of printing the IP address rather than the host name. That is the purpose of n. Now we can also validate against Apache 2 or SSHD. Let me validate against SSHD. In this case, I am not adding capital P, but I am saying n. Let me hit enter. Now you can see that the host names are actually replaced with the actual IP addresses associated with the host names. This is how you should be able to interpret the control arguments that are used as part of this very important command. -na capital P will give us the actual details associated with IP addresses and port numbers. You can actually add additional control arguments such as -p to get details based on process ID or -c to get details based upon command. But whatever filter criteria you have, if you want to combine them, you have to use A. A means end. Make sure you understand these control arguments and also make sure you are really comfortable with this command called as lsof. As we understood how to get the open file details based upon process ID, now it is time for us to explore how to get details about open files using port number as criteria. Let's go to those details as part of the next lecture. As part of this section module, we are going to the details related to monitoring and managing Linux servers using system commands. At this time, we are actually exploring a command called as lsof. Already we have seen how to use lsof to get details based on process ID in the previous lecture. Now let's go to the details, how to get the open file details based on port number. The command is very straightforward. You just have to say sudo lsof -i, then tcp:22. You will get open file details based on the port number. However, it will not give us details about all the open files associated with this process related to port number 22. Now, if you want to get all the open file details associated with the process associated with port number 22, then we have to use -p and pass the process IDs. We should be able to get details about all the open files associated with those processes. Already we have seen those details as part of the previous lecture. Now you can actually say lsof -p, then process ID 702. You should be able to see all the open file details associated with process ID 702. I guess you can also pass process IDs comma separated. Let's try passing process IDs comma separated here to get details about all the process IDs associated with port number 22. In this case, the other process ID is nothing but 39786. There is a typo. Let me fix it. Now let me hit enter. Now you can see the details not only for the first process ID but also 39786. This is how you should be able to get details related to port number first, which will actually give us the process IDs. Using those process IDs, we can actually run the lsof command using -p, and we should be able to get details about all the processes associated with the port number. Let's also explore using Mongodb. Mongodb actually runs on port number 27017. To get a list of processes that are using port number 27017, we should be able to use this command. Now you can see the process details. There's only one process. The process ID is nothing but 458. Now you should be able to say lsof -p 458, which will actually give us all the open file details associated with process ID 458, which is nothing but MongoDB. This is how you should be able to get details related to open files associated with a service based on port number. Make sure you are comfortable with it. Many times we might know port number and we might have to troubleshoot issues. This is how you can actually get process IDs based on port number and then take it further. As part of this section module, we are going through the details related to monitoring and managing Linux servers using system commands. At this time, we are talking about lsof command to get a list of open files on Linux. Already we have seen how to use lsof against process ID as well as port number. Sometimes we might want to get process ID based upon a file. For that also, we should be able to use lsof command. Let's understand how to get a process ID for a given file. First, let's check the file and then we'll take it further. As we have set up MongoDB on this machine, as part of var lib mongodb, there will be quite a few files associated with MongoDB. You can see all the files here. Let's say I would like to get the process ID which is actually controlling this file, mongod.lock. We should be able to use lsof command, pass this file name using specific control argument, and you should be able to get process ID and other details. The command will be like this: sudo lsof. You have to use -f. When you use -f, you have to specify double hyphen like this. there should be a space before double hyphen and also after double hyphen. Then you have to specify the path of the file. In this case, the path of the file is nothing but var lib mongodb, then mongodb.lock. Now you can see the process ID and other details that is controlling this file. This is how you should be able to get process ID for a open file. Once you get the process ID, you can manage this process. If you want to kill this process for whatever reason, you should be able to kill. If you want to troubleshoot further, you can actually troubleshoot further. Many times what happens is there might be some other process which should not be controlling this, might be controlling it. You should be able to get those details here, and then you can actually take the required action to fix the issue. This is how we should be able to get the process details that is controlling a file using lsof command. Let's experiment with a few more examples so that you are comfortable with it. Let's say I would like to see the process details controlling the journal. First, let's understand what all files we have in this journal, and then we'll take it further. Journal is primarily to keep track of changes that are happening in database. In this case, let's first run this command to see what journal contain. Then we can take it further. As the user doesn't have any permissions on this folder, I'm actually using sudo. The user that is logged in at this time is nothing but Ubuntu. When it comes to this journal folder, it is owned by MongoDB. Only the owner have execute permissions on this folder, and hence we need to use sudo, otherwise it will not work. Now let's hit enter. You can see the files in the journal folder. Let's say I would like to see the process details controlling this log file. For that purpose, I should be able to use lsof command like this. It is nothing but sudo lsof -f, then double hyphen, then the fully qualified path of the file. Now let me hit enter. The process ID which is controlling this file is nothing but 48,832. If we know the command or service name, we should be able to use lsof-c and we should be able to get the similar details. However, we have to make sure we use grep to filter based upon certain pattern. So in this case, if I want to get the process details controlling mongodb.lock, not only I can use this approach, I can also say sudo lsof then -c. I should be able to specify the command. The command is nothing but mongodb. Then I should be able to say pipe grep mongodb.lock. Now I can hit enter. You can see that it have given the process details that is controlling the file which is nothing but mongodb.lock under varlib mongodb. This is alternative way of getting the details based upon the file, but the more formal way is using -f option under lsof. This is how you should be able to explore lsof command to get details about the process that are controlling files. Make sure you are comfortable with this approach also. This comes handy in troubleshooting certain critical issues. As we have explored quite a few options with respect to lsof, let's come up with a scenario and understand how it can be used to troubleshoot the issues. For this purpose, I'll be using Jupyter. First, let's go ahead and set up Jupyter-based environment in this. Then we'll actually take it further. To validate whether we have Jupyter or not, we can actually say Jupyter and hit tab. You can see that Jupyter is not set up on this. Let's set up Jupyter. For that, I can actually say python 3-m pip install jupyterlab. It will take care of installing jupyterlab on this. However, there is no module by name pip. First, I need to make sure I install pip. For that, I can actually say sudo apt update, then double ampersand, then sudo apt install python 3-pip -y. It will take care of updating the apt lists and also installing python 3-pip on this machine. Now pip is installed successfully. Let's run this command to take care of installing jupyterlab on this machine. Once it is installed, we'll actually start Jupyter Notebook server using Jupyter Space Lab. Let's wait until it is completely installed, then we'll take it further. Now jupyterlab is installed successfully. Let me say nohup, then jupyterlab, then ampersand. However, it is saying fail to run Jupyter, no such file or directory. If you also run into that issue, make sure you type exit, come out of that session and log in back again. Once you log in, your environment will be updated with Jupyter. You should be able to launch jupyterlab without any issues. Now let's say nohup jupyterlab ampersand. Now you can see that jupyterlab is started. However, it have failed. Let's see why it is failing. For that, actually, I can go through nohup.out. Let me say tail nohup.out to see what is the issue. it is actually complaining about unable to import soft Unicode and markup safe. We have to troubleshoot and fix it. Let's copy this. Then let's go to the browser here. As part of the browser, let's paste the error message. Most likely the issue is related to the version compatibility between Jupyter and Python. Let's click on this. It is actually talking about AWS SAM. I have gone through this issue in the past also. Let me scroll down here. There is a solution for this. We just have to run a pip command which will actually address this issue. Let me scroll down here. This is the one which we are supposed to use. We just have to copy this, then go here, then paste, hit enter. It will take care of upgrading AWS SAM CLI. Once it is upgraded, we should be able to start JupyterLab without any issue. The reason why we are setting up JupyterLab and starting JupyterLab is to primarily use lsof to troubleshoot some of the issues. Now let's try starting the JupyterLab. Now JupyterLab is started. By default, it will be running on port number 8888. Let's go to the details here. First, let's validate whether it is up and running on port 8888 or not. In this case, I can say telnet, then localhost, port 8888. You can see that it is able to listen to port 8888 using localhost. Now let me come out of it. In case if you want to get details about the open files associated with the port number, you should be able to say sudo lsof -i, then tcp :8888. It will give us the details about the process ID, which is actually using this port number 8888. You can see here. You can see JupyterLab is running without any issue. Let's say we would like to run JupyterLab on port number 8888 only. As of now, it is working without no gaps. As of now, JupyterLab is running in background because of the no-hop. As we got the process ID, we should be able to use this process ID and kill that process so that JupyterLab is killed. For that, we should be able to use command called as kill -9. Then we should be able to specify the process ID. In this case, the process ID is nothing but 55018. Now let me hit enter. Now it is killed. You can see the no-hop also came out. Now if you run sudo lsof command with tcp 8888, it will not return anything. You can also use telnet command. It will not be able to listen to port 8888 anymore. However, we would like to restart JupyterLab on port number 8888 itself. Before that, let's use a command called as nc. Let's see whether we have nc or not. nc is available. Now let's start a web server using nc on this machine, then we'll take it further. We can actually say nc -lk 8888. It will actually start a web server on port number 8888 on this machine. You can see that it is struck, which means the web server is started. To make sure it is run in background, let me kill this. Now let me say no-hop nc -lk 8888, then ampersand. Let me hit enter. Now a web server is started using port number 8888 in the background. To confirm whether the web server is up and running or not, we should be able to use either telnet command or lsof command. Let's start with the telnet command first. You can see that we are able to listen to port 8888. However, this time it is started using nc, not Jupyter. Let me quit. Let me also use lsof command and see what is the process that is actually using port number 8888. You can see the details here. The command is nc, the process ID is 55048. Now let's try starting JupyterLab on port 8888 and see what happens. We can say Jupyter lab. In this case, I am not using no-hop. Now I have hit enter. You can see that it is started using port number 8889 because 8888 is busy. Let's come out of this. You can hit Ctrl+C to come out of it. When it actually prompt, you just have to say Y. Then it will kill the existing JupyterLab session and you will come out of it completely. You can confirm by running telnet command or lsof command using port number 8889. You can see there is no process which is using port number 8889 at this time. In this case, I would like to start JupyterLab on port number 8888. If you look at the documentation of JupyterLab, by saying Jupyter lab -h, there is a way to actually specify the port number. Let's look at the details here. You should be able to specify the port number using --port. Now I should be able to say JupyterLab, then hyphen port. It can be equal or it can be space. In this case, I would like to start on port number 8888. I'm hard coding the port number here. Let's see what happens. Even though I have specified port number 8888 explicitly, it is still using 8889 because 8888 is not available. Now, if you are not sure why 8888 is not being picked, even though we have explicitly said that, you can use lsof command to troubleshoot which application is actually using port number 8888 and you can take it further. There might be another Jupyter session which might be using this port number 8888, or it can be completely other service. Now you should be able to use lsof command like this with TCP 8888. You should be able to get the details. There is a command nc, which is nothing but a simple web server which is running at this time using port number 8888. If you think it is not relevant and if you want to replace this with a jupyterlab, you should be able to kill this process by saying kill -9, then 55048, which is nothing but the process ID associated with this process. You can hit enter. Now the process is killed, which means the NC based web server is killed. You can validate by running lsof command as well as telnet command. You can see that there is no application running on port number 8888. Now we should be able to launch jupyterlab on port number 8888 without any issue. You can see that this time jupyterlab is started on port number 8888. However, we have ran jupyterlab in the foreground. That's why the screen is being controlled. If we hit Ctrl+C to come out of it, automatically the jupyterlab will be killed, and also there will be no application which will be running on port number 8888. Let me say Ctrl+C, then Y to come out of the jupyterlab session. Now we are out. As we are out of that and as jupyterlab is killed, now if I say lsof, it will not list anything. If you submit this in the background by saying nohup and then ampersand at the end, the jupyterlab will be running in the background using port number 8888. You can confirm whether something is running on port number 8888 or not using lsof command like this. You can see there is a jupyterlab session that is running using port number 8888. This is how you should be able to use lsof to troubleshoot some of the complex issues. That's why I am emphasizing for you to understand lsof command in depth. As we have gone through quite a few details with respect to PS and lsof, now it is time for us to explore another very important command from the perspective of monitoring and managing Linux based servers. It is nothing but top. Let's go to the details related to the top in the subsequent lectures in this section or module. As part of the section module, we are going through the details related to monitoring and managing Linux servers using system commands. So far, we have gone through the details about installing softwares, managing the services associated with the softwares, and also we have gone through the details related to PS command as well as lsof command. Now it is time for us to explore another very important command called as top. Before going to the details related to the top, let's understand how to get details about running applications using Windows. Then we'll get started with the top and we'll cover quite a few important details related to top in the subsequent lectures in this section or module. As part of Windows, we have Task Manager. We should be able to use Task Manager to get details about all the running applications. You can actually click on this to go to this pop-up. Then you should be able to search for Task Manager here to go to the Task Manager. You can click on this. By default, you might get into the fewer details view. If you want to get all the details about running applications, you have to click on more details. Then you should be able to see details about all the processes and applications that are running on Windows at any point in time. These are the processes that are running at this time. The apps which I have launched since I start this Windows machine are nothing but Google Chrome, Task Manager and Windows PowerShell. However, there are quite a few other applications that are running in the background. They are called as background process. You can see that there are 44 background processes. On top of application details, it is also very important for us to understand the performance of a system. For that, you should be able to go to the performance and you should be able to review the details here. This one will give you the CPU details. This one will give you the memory details. This one will give you the disk details. This is related to the C drive. This is related to the D drive. This one will give you the details about network, which is nothing but Ethernet. This is how you should be able to get details about your system on Windows. In case if you want to get these kind of details on Linux, especially using black screens like this, you have to use a command called as top. This is where top comes into picture on Linux. Let me say top here. this session is hung. I have to come out of it. In case your session is hung like this, you can actually say shift, then tilde, then dot. It will come out of it like this. Tilde is the character which you have on the left side of number 1. You have to hit shift and then that key, which is nothing but tilde, then dot. It will come out of that session completely. Now you have to log back in case if you want to connect to a remote machine to explore something. Now I'm logging back in onto my Ubuntu based machine provisioned from AWS. To understand the performance of this Linux based system, I should be able to use top command, and you can see the details here. On top you got the summary about CPU. These are the details related to CPU. These are the details related to the memory. These are the details related to the threads. This is the summary details. These are the actual application details. The way we have seen the application details on Windows. Let me go here. I have closed the task manager. Let me launch task manager once again. You have process and the performance. Here you got the consolidated view of your system. The top section of top actually gives you these details. The bottom section of the top will actually give these details. Whatever process that are running on that Linux server will be shown here. This information will be refreshed quite frequently. Let me run top command once again. Frequently this information will be refreshed. You can see here. Earlier MongoDB is on top. In between it went to root. Again we got back on to the MongoDB at the top. This is how you should be able to get started with the top. Now top is very powerful. You can actually customize the view. You can also switch to different views. You can also manage the process directly from here. Even using task manager, you should be able to kill a process. For example, in this case, let's say I have launched the task manager. Let's assume that Google Chrome is taking too much resources and we would like to kill it. We should be able to select Google Chrome and we can click on end task, and you can see that Google Chrome is killed. We should be in a position to perform such kind of tasks on Linux also. We should be able to use top and take care of those directly using top. You can also pick the process ID, come out of the top, and then use kill command to kill. However, we should be able to kill directly from the top interface itself. That being said, as we got an overview of top, now let's get into some of the important aspects of top so that you can effectively use it based upon your requirements. As we got an overview of top command, let's see how to get usage or help of top command as well as man page of top command. For most of the Linux commands, typically we use -- help to get the help. However, with respect to commands such as lsof, top, etc., we should be using -h. It will give us the usage of the command here. You can see there are quite a few options with respect to top. To get more details about these options, you should be able to go to the man page by saying man top and hit enter. Now you should be able to get all the details related to the top command. Top is robust command. It have quite a few details and also it is interactive. Based upon what you are exploring, you have to go to appropriate section and you can take it further. It starts with command line options. Then as we have seen, when we actually launch top, you will be seeing summary details at the top. The details are related to uptime and load averages, threads and memory usage. If you want to get more information about the summary, you should go to the summary section as part of the man page. You can also get the details about fields and columns that are displayed when you actually launch top. Also, you should be able to interact with the top. There are quite a few commands which we'll be exploring, and also there are quite a few things which we will not be exploring. In case if you want to get any details with respect to those interactive features, you can actually go to the interactive commands section. Like this, there are quite a few other sections. You just have to explore based upon your requirement. You can actually go to the details with respect to the command line options. Command line options can be used to control the behavior of the top command. You can actually run top command in the batch mode. You can also control number of times the top command should refresh before it quit, and also the frequency. The frequency can be specified using -d. The number of times it should refresh before quit can be specified using -n. You can see number of iterations when it comes to the -n. This is how you should be able to get details with respect to the top command using either -h or man page. Now let's quit. Now let's say I would like to just refresh twice and come out of it automatically. In that case, I should be able to say top. Then I should be able to specify -n2. it will just refresh twice and it will come out of it automatically. You can see that it came out, it have refreshed twice in between. This is how we should be able to get helper usage of top command and also the man page. Make sure you understand the details. As we understood how to get the helper usage as well as man page of the top command, let's perform few tasks so that we are comfortable with the top command. We'll be performing quite a few tasks as part of the subsequent lectures in this sectional module. At this time we are exploring top command. First, let's review the usage once again by saying top-h. Now, let's understand how to control the behavior of the top command by using some of these command line options. Already we have seen details with respect to -n, where we have specified to refresh twice and come out of it automatically. You can also control the refresh by using -d. By default, I guess it will be refreshed every 3 seconds. I'm not 100% sure. If you want to refresh every second or every 10 seconds, you can use -d and you can specify the number of seconds. You can combine these options. For example, if you want to refresh every 2 seconds twice before coming out of it, you can actually say top-d to -n2. Then it will actually launch the top. It will refresh twice every 2 seconds and then it will come out of it automatically. You can also specify the username by using -u so that you get details about the process owned by specific user only rather than getting details of process owned by all the users in the system. You can also specify the list of process IDs comma separated using -p. Like this, there are quite a few options. You should be able to use these options and control the behavior of your top command. You can also run top in batch mode so that it actually come out of it automatically by printing the result. You just have to say top-b -n1. It will just get the output once and it will come out of it. -b with -n1 comes handy as part of our scripting. Now let's go to the details about how to get the details of all the process owned by a specific user. And also I would like to just refresh 5 times every 1 second before quit. For that purpose, I just have to say top-d1. It will be refreshed every 1 second. I would like to refresh 5 times and hence I can actually say -n5, then -u. Let's specify the username. It is nothing but dgadraju. Now you can see the details here. It is refreshing every 1 second. There is not much activity happening here. That's why we are not seeing screen being refreshed here. However, after 5 seconds, it came out. Now let me connect to the EC2 instance which is provisioned from AWS, then run the top command on it. The top command which we have explored is nothing but top-d1 -n5 then -u. In this case, the username will be Ubuntu. Now let me hit enter. It is refreshing every 1 second. It have refreshed 5 times and it came out. This is how you should be able to use top to get the information you are looking for by customizing it using command line options. Now let's go to the details related to the interactive options. We'll be covering quite a few details in multiple lectures in this sectional module. As part of this section module, we are going through the details related to monitoring and managing Linux servers using system commands. At this time, we are talking about top command. Let's understand the output that is generated when we actually use the most basic top command, which is nothing but top itself without any options. As I have explained earlier, at the top, you will be getting a summary of the system. You will get CPU or load average memory details as well as threads or process details. At the bottom, you got the process level details. If you look at the columns, it actually display PID, user, PR. I don't know what PR is all about. You can actually go to the documentation and you should be able to understand. NI stands for nice. Don't worry too much about PR and NI at this time. Vert is nothing but virtual memory. Res is nothing but resident memory. SHR is nothing but shared memory. These three are related to memory. Then I'm not sure about yes. This is percentage CPU, percentage memory, then time plus. I'm not 100% sure about what this time is. You can actually go to the documentation and understand. Finally, you can see the command. This is the one of the standard views which is provided to us. There are 3 others. Those are called as groups. You should be able to switch between the groups. I'll be covering those details very soon. You can also customize the behavior of this screen by getting whatever details you want. You can actually hit Q to come out of it. If you say top-h, you should be able to see the usage. You can actually specify -o and you should be able to specify the fields which you wanted to display when you run top command. However, I will not be covering details with respect to -o. You can also customize the behavior of the output that is displayed here. If you want to remove certain fields, you can remove, you can add more, you can also change the sorting behavior. To take care of those things, you can actually use F key. Once you launch top, to interactively get details about how to customize this, you can hit F. You can see that we are in this. It is primarily for the field management. You can see here. When you hit F, it got into field management. If you want to go back to the original window where we got the system as well as process details, you can hit Q. F to get into the field management. To come out of it, you can hit Q. It will go back to the original window. Now let's say F to get into the field management. Now if you observe this, there are quite a few fields here. This is one field, PID, then user, PR, and then you have up to SID. You also have additional column here and also additional column here. This one also have columns such as NTH, P, time, swap, so on and so forth. Even this one have columns such as NSPID, NSUser, NSUTS, etc. However, if you look at these ones from PID to command, these are highlighted in white and also there is a star before them. These are the ones which are visible here. If you want to disable certain fields, let's say I don't want to see PR and NI, we can actually select, hit space. You can see the star is gone and also it is grayed out a little bit. You can also select NI and hit space to deselect. So you can use space to toggle between enabling and disabling. Let's disable quite a few things. I have disabled almost 6 fields. Now if I hit Q, you can see that we are getting limited information. The information for PID, user, percentage CPU, percentage memory, time plus and command are visible here. Others are not visible because they are disabled. Also, when you get into the field management, you can see that percentage CPU is selected. Let me hit Q. Let me hit Q again. I came out of it completely. Let me run top command again. Let me go to the field management. You can see that percentage CPU is highlighted. It is because by default for the view which we are getting, the data is sorted based on CPU. You can actually go back to this window and you can observe here. The process which is taking most amount of CPU is at the top. You can actually switch the sorting to some other field again by going to the field management. You can also get the details about the field that is being used for sorting at this time. It is nothing but percentage CPU. Let's say I would like to sort based on memory. In this case, I have to go to percentage mem here and then I have to hit yes to change the sort based on this field. You can observe here. Once I hit yes, the sort field is changed to percentage mem. Now if I hit Q to go back to this window, this time data is sorted in descending order by memory, not by CPU. We can also change it to command or PID or any other field which we are interested in. Let's go to the field management again. Now let's go to PID. Then let's hit yes to sort by PID. You can see the field is changed to PID with respect to sorting. Now you can hit Q. Now you can see that data is sorted in descending order by PID. The default behavior is sorting in descending order based upon the field that is chosen. This is how you should be able to use F to go to the field management and control the behavior of the top screen. Top is the interactive command. You should be able to use effectively and customize the window based upon your requirement. As part of understanding top command, in the previous lecture, we have gone through the details about customizing the top interactive interface. Now let's explore the details about different groups that comes out of the box as part of top interactive interface. Let me use the top command to get into the top interactive interface. The default group is 1. As part of the group 1, we'll be getting these details. You can actually review the fields that are associated with this group by hitting F. These are the fields which are displayed as part of the group 1. To switch between the groups, you have to go to the top interactive window, which is nothing but this one. Now you can hit G. It is saying choose field group from 1 to 4. Now if you say 2, it will switch to this view. In this case, this group contain PID, PPID, time, percentage CPU, percentage memory, so on and so forth. You can get the details of fields that are chosen as part of this group by hitting F again. You can see what all fields that are part of this group. This is related to job. If I go back, if I hit G and if I hit 1 and if I now hit F, if you look at this, it is saying def. So this is group 1, which is related to def. I don't know what def means. You can actually go to the documentation. Now if I hit Q, then if I hit G and then choose 2, when it comes to the category, it is nothing but job. These are more tuned for the job. Like that, we have 2 other groups also. Now let's hit Q to come out of this. Now let's say G, then hit 3. This is the group 3. You can actually hit F to get into the field management. This is nothing but memory group. This will actually give more details related to the memory compared to others. That's why it is called as mem. By default, the sorting is based on the percentage memory. When it comes to 2, where it is job, I think the sorting is done by process ID. We can hit Q, then say G to go to the group 2. We have to hit 2 here. Now we can hit F. You can see that when it comes to group 2, the data is sorted based on PID. Now let me hit Q, let me hit G, let's choose group 4, let's say F. This time it is related to user. The data is actually sorted based upon user field. This is how you should be able to switch between the groups and also understand what is being provided to us in each of the groups. These are the standard groups. You can also customize by choosing appropriate fields and deselecting the other fields to get whatever field information you want as part of this top interactive interface. As we have understood how to interactively change the groups, now let's understand how to kill the process or manage the process using top. As part of this section module, we are going to the details related to monitoring and managing Linux servers using system commands. At this time, we are exploring top command. We have gone through quite a few details with respect to top command. In this lecture, let's understand how to kill process using top command. Keep in mind that you will be able to kill only those processes which are owned by you unless you get into the top using root. Let's start with the top here. We should be able to see all the details about the process that are running on this server at this time. Once we log in, let's assume MongoDB is taking too much resources and we want to kill MongoDB process. In this case, the process ID is nothing but 48,832 with respect to MongoDB. To actually kill the process interactively using this top interactive interface, you have to first hit K. Now you can see that it is asking for PID to signal or kill. The default is 48,832 because at the time it is the top one. However, if you wanted to change, you can change. If you wanted to kill this, you can hit enter and it will attempt to kill. Let's hit enter to kill. Now it is asking us to confirm whether we wanted to kill the process ID 48,832 or not. You just have to hit enter to confirm. However, it have failed because the process is not owned by the user that is logged in, which is nothing but Ubuntu. Only root or MongoDB user can actually kill this process. Now let's come out of it by saying Q. Now let's say sudo top. In this case, I'm launching top as sudo. Now let's hit enter. Let's type K, where we'll be getting prompt to enter the process ID. Let's choose 48,832 itself. Let's hit enter to confirm. Now you can see that the process is killed. It is gone. It will not come up anymore. You can actually come out of it. Then you can actually say ps-ef. Then grep 48,832. You need to review here. There is no process with 48,832. The reason why we are seeing this entry is because there is a process which actually ran this. This process is related to that process. The process ID for that process which have actually ran this command is nothing but 55,664. MongoDB process itself is dead. You can also confirm by saying sudo systemctl, then status MongoD. You can see that it is dead. Now you should be able to start it by saying systemctl start MongoD. Now it should be started. You can validate by running status again. As it is started, now if we say top, we should be able to see MongoDB as part of the top interactive interface. You can see the entry here. This time the process ID associated with the MongoD is nothing but 55,679. Now let's come out of it. Let's launch jupyterlab on this. In this case, I'll be launching using NoHub. We have already set up jupyterlab earlier. Now let's validate whether jupyterlab is up and running or not by using lsof, then -i, then TCP:8888. that is the port number on which jupyterlab is supposed to run. You can see that it is running. The process ID is nothing but 55,105. Now let's say top, hit enter. You can see that it is not visible here. Even after waiting for some time, I am not able to see any process related to Jupyter. We should be able to come out of it. This time when we launch top, let's say -u, then Ubuntu. We'll be able to see only those processes owned by Ubuntu user. Now we should be able to see that process where jupyterlab is running. There are two of them. One is 55,105, second one is 55,730. I'm not sure why we have two. Probably one might be parent to the other. As of now, we can see two processes. In this case, if we want to kill 55,105, we can actually hit K. Then we can actually say 55,105. Hit enter to confirm. Now 55,105 is being killed. Now it is killed. Still there is another jupyterlab with 55,730. If you wanted to kill, you can kill that one as well. Probably it might be running using port number 8889 when we actually launched earlier. You can confirm by actually coming back here, and then you should be able to say lsof-c, then jupyter space lab. You can see there is a process running. You can also get the port details by saying -i TCP. Also, we need to use -a here so that it actually get the details only with respect to command jupyterlab and TCP interface. You can see here, this is related to port number 8889. If you want to kill this, you can use top. You can also use kill -9 and you should be able to kill. In this case, let's say top -u, user is nothing but Ubuntu. Now I would like to kill 55,730. For that I should be able to say K, and then I can enter 55,730 to kill that process. Now it is also killed. We can come out of it. Now we can validate whether jupyterlab is still up and running or not using this. As of now, there is no process which is running based on command called as jupyterlab. This is how you should be able to use top interactive interface to kill the process without coming out of it, and then by using kill command. You just have to hit K once you are in the top interactive interface. Then it will actually prompt you to enter the PID. Once you enter PID, as long as you have permissions on that PID, you should be able to kill it without any issues. As part of this sectional module, we have gone through quite a few details with respect to monitoring and managing Linux servers using system commands. We have explored how to install softwares using apt, and also we have gone through the details about managing the services associated with the softwares using systemctl. Then we have actually gone through the details related to commands such as uptime to get CPU or load average. Then we have gone through the details related to the commands such as ps, lsof, top, etc. To take care of demonstrations related to these important commands, I have made sure that I have provisioned a full-blown Ubuntu-based machine from AWS. As we are done with this sectional module, it is time for us to clean up that EC2 instance. Make sure you terminate if you have provisioned the AWS instance for the practice, so that you will not be charged or you will not be wasting your free tier resources or free tier credits. In this case, I have gone into the EC2 management console. Let me refresh this so that the session is still active. It might prompt me to log in. You can see that it have prompted me to log in. In this case, I have to log in. Once I log in, I should be able to terminate the instance without any issue. I have to enter the code here. Let me enter the code. Let me actually go back to aws.amazon.com. Let me sign into the console. Now I'll be re-entering the code and I should be able to log in without any issue. Now I'm in the AWS console. Once in the AWS console, I should be able to go to EC2. Then I should be able to search for the instance which I wanted to terminate. It is nothing but the instance which have name called as syscommands-demo. Now let me select this, go to instance state and then click on terminate instance. Let me click on terminate instance. It will take care of terminating the instance. Make sure you terminate the instance, and also if you are new to this, make sure you wait until the instance state is changed to terminated. You can see that it is in shutting down. Most likely it will be terminated without any issue. Make sure you go through this sectional module and understand all the important commands that are covered. try to experiment as much as you can so that you get enough practice. These are the very important commands for you to troubleshoot any of the issues in Linux.